Hey everyone, so in this video I'm going to introduce the MVVM architecture for Android development. So what I want to do now is we're going to go through a bit of theory on why you might want to use MVVM and a few of its features, and then we're going to go to Android Studio and build a very small sample application so you have a practical example of how to actually implement this architecture in practice, right? So MVVM, what is it? Basically, MVVM stands for Model View View Model, and it's basically a way to separate your code in Android development in three major components, right? The model is going to contain data and business logic. So all the functionality to produce some useful information or to retrieve some information from anywhere, to transform that information in any way, that is the model, okay? The model is kind of the major part of this MVVM architecture that gives you the information that you want to display to your user. The view is the display layer, so it's basically what we use to actually show whatever information we have to our user, right? And it's composed of what you might expect, activities, fragments, layouts, and so on. And then we have the view model, which is basically going to connect the two other components. It sits between the view and the model, and it provides lifecycle management and data availability. So it basically takes the data from the model and allows the view to actually display it in a way that manages lifecycle for both the view model itself and the view. So here is a quick diagram of how this works. So basically we have the view model here in the middle that relates to the view. So basically the view model, importantly in MVVM, the view model has no idea, doesn't have any references to views. Basically it implements a observable pattern, and the view simply connects to the view model and receives data updates and information updates. So the view model doesn't know about the view. However, the view, of course, knows about the view model. So the view model simply provides data information based on this observable pattern. Whereas the relationship between the view model and the model can be more direct. So basically, the view model can send data to the model whenever it is, it makes sense to do so, and the model sends data back to the view model. So there's a flow of data between these two. That is the major structure of MVVM. So what is the difference between MVVM and MVP? You might be used to MVP. It's a slightly older pattern that we were using in the past for Android. MVP simply means Model View Presenter, and we have renamed the presenter to View Model. Now, there's more to it than just this change of name. Basically, the most important change is that the presenter references the view to transmit data directly, so to call functions on the view. However, the view model holds no reference to the view, okay? So the view model doesn't care who subscribes to its event. It simply provides that as some data source that a view or multiple views can connect to. So there are two major components in an MVVM architecture from a Google standpoint. By the way, MVVM is not only specific to Android, it is a pattern that can be used throughout multiple development languages, multiple projects, multiple targets, right? So it's not created by Android, but it's just adopted by Android for our uses here. Now, the two major components are, one, the view model. The view model simply manages lifecycle for the class view model, right? And the LiveData. The LiveData implements the observable pattern that we are using in our MVVM architecture, right? So the view can connect to events, to subscriptions of live data in our view model. Now, if this doesn't make too much sense, don't worry. We will go into Android Studio and build an application to show you how to implement this in a very simple way, just focusing on the MVVM architecture. So the application that we are trying to build will look something like this. We want to simply display some image of a city and some other information, for instance, the name of the city and the population, right? and we want to switch between these, between different cities, different information here. The data for all of this will be locally generated. Okay, we're going to simulate a local generator. Of course, in a real-world application, you might connect to a database, or you might receive that information from the web. For us, we're going to keep it simple since we want to focus on the MVVM part, the architecture part. So we're going to generate the data locally. We're going to have the ViewModel receive that data from the generator and display it to the view. So this for us is going to be the model, and we're going to implement a ViewModel and view for displaying the data. All right, so now let's move to Android Studio, and we're going to go ahead and implement this application. All right, so in Android Studio, we're going to go ahead and create a new project. I'm going to use an empty activity for this one, and I'm just going to give it a name. You can give it whatever name you like. Of course, it doesn't matter. I'm going to go MVVM Cities. Okay. All right, we're going to wait few seconds for that to finish building. Okay, so that is done. Right, so let's go ahead and implement it. I'm going to open up the build.gradle with double shift. So double shift opens up the search pop-up here. And I'm going to enable view binding down below. So inside our Android block, I'm going to say build features, view binding equals true. If you're not used to, let me just sync that. If you're not used to view binding, I have a few other videos that talk about that, and there's some links in the description as well if you want more information. All right, so let's go ahead and start to implement our UI. So first of all, I'm going to open up my main activity here, and I'm going to remove this hello world, and I'm going to add some elements here. So first of all, I'm going to add an image view. All right, let me just add some images before we do that. So here inside the drawable, I have actually downloaded a few images of some cities. You can go and download from, from the web, whatever cities you like, or you can just get them from the code that I put down below in the description. So I downloaded these. I'm going to click and drag them to my drawable. I'll try that again. All right. So refactor. So now I have some images in my code. And Android Studio annoyingly opens them all. So let me just close them. Okay. And I have my main activity. So back to where we were, I'm going to add a image view with, let's say, Bangkok for default. You can see there's some white spaces here, so let's remove that. Here, the height is going to be wrap content. That's fine. I'm going to do scale type fit XY, and then adjust view bound to true. Okay, so that should get rid of the spaces, and I'm going to infer the constraints here. Okay, infer constraints. I'm going to remove the margin. For some reason, it puts the margin like that, very ugly. And we have start to start off, top to top off. I would like to add right to right off parent as well. Okay, so we have that right at the top, nice and easy. So I'm going to put image city image as the ID. Okay, so I have my image view. That is fine. Now I want to put two text views because I want a name of the city and the population size. Okay, so I'm going to have a text view here with wrap content, wrap content. I'm going to give it an ID of city name TV for text view. Okay, I'm going to put some text here, city name. I'm going to give it a bit of padding, like 10 dp. That should be good. I also want to have the text size somewhere around 25 sp. Be careful, that's sp, because we're dealing with text. And then that's it. We also need the constraints. So I'm going to put start to start of parent, end to end of parent. So it's centered right in the middle. However, the top is going to connect to the bottom of city image. Okay, so if we look in the design, it should be, sorry, that's constraint top to bottom of city image. Okay, my mistake. Okay, so I have my city name and I want another text view for the population size. So I have text view, wrap content. I have an ID of city population, TV for text view. I have a text. The text, let's say, should be population. Okay. The padding is 10 dp. The text size, I'm going to reduce it a bit. I'm going to put 15 sp for this one. And then very similar constraints. So start to start of parent, end to end of parent, and then top to bottom of, and we're going to use the city name TV here. Okay, so if we look here, we have city name and population. Okay, so that is our UI. Now, I'm going to go ahead here in my Java folder. It says Java, but of course, you know, we can use Kotlin. And I'm going to add three package names. One is going to be model. One is going to be view. And the third one is going to be, you guessed it, ViewModel. And I'm just going to move my main activity inside the view. Okay, activity is part of the view, so I'm going to refactor that. Okay, if this doesn't actually move for you, that's okay. It's just a bug of Android Studio. I'm going to rebuild the project, and that should help us solve the problem. Okay, so now it's moved here, that's fine. So let's go ahead and start to implement our model. I'm going to create a new data class. So I'm going to select data class here, and I'm going to call this city. The city will have three variables, so val name of type string, val image of type int. It's going to be int because it's a resource of Android Studio, so this is an integer. And it's going to have population, also an integer. Okay, we have our city. Now let's go ahead and create a new class, and I'm going to call this city data provider. Okay, this will have a private val cities equals, it's going to be an array list of city. Okay, I'm going to initialize it with all the cities that we have. So cities.add. I'm going to have a new city. And I'm going to leave the name open for now. Add drawable.bangkok. Import that. And then some population size. So I'm going to leave that open for now. I'm just going to copy and paste it 10 times so I can fill out the information. So I have Bangkok. Then these are in alphabetical order here. So I'm going to say Beijing. Then we have London and New York. New York. What else? Paris. We have Rio de Janeiro. We have Rome and Singapore. And then we have Sydney and Tokyo. Okay, so drawable Bangkok. This is Beijing. This is London. This is New York. Paris. Rio. Rome, Singapore, Sydney, and Tokyo. That's fine. And we also need population. Now, for the population, I've gone ahead and searched Google for each of these. The results might be more or less accurate. So this is the result that Google gives me for each one. So Bangkok, I'm going to say 10 million people. Okay. The underscore here is just a separator for the editor. It's not going to be shown like this in the when we actually display this on the screen. It's just a separator for clarity here. All right, Beijing, 21.5 million. Okay, London, we have 8.9 million. And New York, 8.4. Okay, Paris, 2.1. Then we have Rio is going to be 6.7. Then Rome is going to be 2.8. Okay. This really depends on what each individual city considers its like inner city. So that's why the numbers are so strange, I would say. Singapore, 5.7. Then we have Sydney, which is 5.3. And Tokyo, 13.9. All right, so we have that. You can, of course, put any numbers here that you like. It doesn't really matter to the functionality of the code. So that is our model. We have our activity, which is our view, which we will work on a bit later as well. But for now, let's go ahead and put a view model. So create a new file. I'm going to call this city view model. And this is going to inherit from view model. Okay, so this will basically handle the lifecycle of the view model here for us. Now, inside here, I'm going to have private val city data is going to be a mutable live data that takes a city and is instantiated. So let me just import that. All right, so we have live data that we talked about. Basically, this allows a view to subscribe to events and receive notification whenever the value of this data changes. It is mutable because mutable allows the value to change. If we only have live data, the value doesn't actually change. So we need mutable live data here. Okay, now we have a list of cities. So private val cities is going to be city data provider dot. I think I forgot to put the access method. So in city data provider, I'm going to have fun get cities, and it's going to return cities. Okay. So here we use that method, get cities. Okay. We have private val index, current index is going to be 0, which is the current city that we are displaying. And what I will also like to do is I would like to automatically cycle through all these cities in our view, right? So I want to update this city data periodically and display new information every few seconds. Okay, so we have a certain delay. I'm going to call this private val delay is going to be, let's say, 2000 L, which is 2 seconds. One thing I need to change here, current index needs to change at some point. So this is going to be a variable var. Okay, now let's go ahead and create a function that will update the current city. So private fun update city. So how are we going to do that? First of all, current index plus plus. So we increment the current index, but we got to make sure that it doesn't grow beyond the size of cities. Okay, so I'm just going to say current index. I'm going to use modulo function for city.size. Right, so when it reaches the size of the city's array list, it goes back to 0. That's all that this does. Then we have cities data.value is going to be cities of current index. So basically I'm updating the live data. And then I need a function to loop again and get a notification after another 2 seconds, which is my delay, right? So I need a function called loop. All right, so let's go ahead and implement the loop function. So I'm going to have private fun loop. Now for this, I'm going to use the handler in Android to get a callback after a certain delay. So I'm going to say handler. Make sure you're using the one in Android OS, okay? Handler. Instantiate that with the looper dot get main looper. Okay, looper is going to allow us to loop for every X amount of seconds. Dot post delayed. And here, of course, we do some code after our delay. Okay, and that some code is going to be very simple. It's simply going to be update city. Okay, so every 2 seconds, we're going to call update city, and then we're going to loop again. However, the first time we create this class, we need to start the loop. Okay, so I'm going to put that inside the init. I'm going to put a loop here. Okay, easy enough. Now let's move on to the final component, which is the activity. So here, since we're using view binding, I'm going to instantiate to create a binding variable. So private late init var binding equals is of type activity main binding. This class was generated automatically for us based on the layout here. So I'm going to instantiate it inside of my onCreate function. So binding is going to be activity main binding dot inflate with my layout inflator. And I'm going to remove the parameter here. I'm going to say binding dot root. Okay, easy enough. Now, down below, I'm going to override the onResume method. And here I'm going to connect to my ViewModel and observe the variable. Now, for that, we need a reference to the ViewModel. So private val model of type city ViewModel. Now, for the ViewModel, you're not allowed to actually instantiate it yourself because this is not an instance. This is a ViewModel. We let the system handle our life cycle, right? And we have a very nice convenience method that Google provides to allow us to use this ViewModel in the right way. To use that, we're going to add another library to our Gradle build. So I'm going to open up build.gradle. Okay, and here down below where I have my dependencies, I'm going to add an implementation. Right, so here I'm going to add AndroidX.fragment fragment minus KTX Kotlin extensions, okay, :1.3.6. Okay, so this will provide a function for instantiating the ViewModel for us. I'm going to let that sync. Going back to my main activity, here I have city ViewModel by ViewModels, open bracket, close bracket. So import the city ViewModel. I'm missing an S here, so ViewModels. And we need to import this function as well. All right, so that takes care of the instantiation. If we do it like this, the advantage is that whenever the activity is killed and recreated, we don't reinstantiate the ViewModel. The system basically provides the existing one for us and passes it to our model variable. Okay, so very important. Now, in our onResume, we're going to say model dot. We need the access method. Okay, so I need in my model, I need to have somewhere here fun get city data that will return a type of live data of city, and it will return city data. Okay, so we want to give city data, but simply as a live data, so the user cannot modify the value. So here we have model dot. There's a bit of mistake here. Let me just try to fix that. Okay, so model dot get city data dot observe. We need the owner for this lifecycle, which is going to be the activity. And then we have an observer. The observer receives a city and simply updates the UI. Okay, so I have binding.cityImage.setImageDrawable. This is a bit complicated, but just because Android makes it complicated to update the image drawable in our layout. So I'm going to say resources compat.getDrawable. I'm going to pass the resources city.image and application context.theme. So you can see it's a bit complicated, but Android likes to complicate things for no reason. So it is what it is. Then we have binding.cityNameTV.text is going to be city.name. And then we have binding.cityPopulationTV.text is going to be city.population. .toString. Remember, this is an integer. All right, so I think that is it. Unless I've made any mistakes, that should run fine. So let me just go ahead and run this in an emulator and see what output we get. All right, so there we go. We can see that our UI is updating correctly. This is all functionality that comes from our model, and then the ViewModel simply connects between the two and provides our functionality periodically every 2 seconds in our case to update the UI. We don't actually need to do anything. It just updates by itself. Also important to know, the activity knows about the ViewModel. However, the ViewModel doesn't know about the activity. It doesn't know who connected to this. It just knows that it needs to update its local variable here. That is that's what is very powerful about the MVVM architecture, this separation of concerns. So later on, if we want to test these components separately, then we can. It's not connected. The ViewModel is not actually connected to the view and so on. So we can test it separately. All right, that's it for this video. If you want more information, check out the description box down below where I've put a few links with more useful information like this. Have a look at that. And that's all for now. Thank you for watching, and I'll see you in the next video.